Petrix method. It is also used to minimize the SOP. Actually, in Quinn-MC-Klasky method, okay, there may be two minimum solutions in prime implicant chart. But by using this Petrix method, it is a systematic way to find all minimum solutions from the prime implicant chart. So, we are doing this Petrix method. Okay. The first procedure is same as MC-Klasky method. Okay, that is, this is the SOP, given SOP. Now, we need to write the min terms, that is 0, 0, 0, 0, 1 as grouping, 2, 5, 1, 0, 1, 6, 1, 1, 0, 7, 1, 1, 1. Now, these are grouped. Okay, this is the stage 1. Stage 2, compare these two groups. If there exists only one bit position changing, then pair it. Okay, yes, 0, 1, 0, 1, only one difference, that is 0, 0 hyphen. Okay, next 0, 2, that is 0 hyphen 0. Completed first group. Next 0, 0, 1, yes, 1 with 5, it will be grouped, that is it is changing hyphen 0, 1. Next 1 with 6 is not possible because 1 is changing to 0, 0 is changing to 1, 0 is changing, no, not possible. Now compare with the 2, that is 2 is not possible because 0 is changing as 1 and 1 is changing to changes, not possible. Next compare this with this, yes, it is possible. So group this 2, 2, 6, that is first position hyphen, next position 1, 0. Next these two. 5 with 7, yes, it is possible, 1 constant, next changing, next constant. Next 6 with 7, yes, possible, 1, 1 hyphen, because it is changing. Now these are the prime implicants. Okay, from this we are constructing the prime implicant chart and finding the essential prime implicants using MC-Klasky method, right? But here we are writing the prime implicant chart, that is prime implicants with min terms. Okay, prime implicants, these are all the prime implicants. Name it as P1, P2, P3, P4, P5, P6. And what is P1 is 0 combined with 1 pairing. So this is when you take A, B, C variables. Now A bar, B bar. Next P2, that is 0 with 2. A bar, C bar. 3, 1 with 5. That is B bar C. Next 2 with 6. B C bar. Next one 5 with 7. A C. 6 with 7. A B. Okay. Now write the min terms, that is 0, 1, 2, 5, 6, 7. First min term. Okay. Place the cross, that is 0, 1. Next one 0, 2. So 0, 2. Next 1, 5. So 1, 5. Next 2, 6. 2 with 6. Next 5, 7. 5 with 7. 6, 7. 6, 7. check here. Actually 0 is covered 2 times. Okay. 1 is covered 2 times. All were covered 2 times. So there is no essential prime implicant from this. If you want, you check this. Yes. So we are going for the next procedure, that is, now you group the prime implicants, that is P1, P2, where because these two were covered with min term 0. So finally represent Petrix method with P, capital P. So P1 plus P2. Next P1 with P3, because it is covering P1, P3. So right here P1 plus P3. Next P2 with P4. P2 plus P4. Next P3 with P5. P3 plus P5. Next P4 with P6. P4 plus P6. Next P5 with again P6. P5 plus P6. Now we'll simplify by using this method, that is, using distributive law, this will become P1 plus P2 P3. Next coming to these two, okay, P4 distributive law plus P2 P6. Next coming to these two terms, P5 plus P3 P6. P1 with P4, P1 P4 and P1 with P2 P6. Next these two, that is P2 P3 P4 plus P2 will get 2 times P2 P3 P6. This you can write only once P2. This becomes P2 P3 P6 into P5 plus P3 P6. Okay. Now again you do the same process for P1 P4 P5 plus P1 P2 P6 P5 plus P2 P3 P4 P5 plus P2 P3 P6 P5 plus again repeat this for this two, that is P1 P2 P6 P3 P6 again repeated, so no need to write, only one time is enough. P1 P4 P3 P6 plus P2 P3 is repeated 2 times, write only one time, P4 P6 plus here P2 P3 repeated, only write one time, and P6 repeated only one time. Use x plus xy is equal to x to eliminate the redundant terms. Okay, now we'll eliminate the redundant terms, that is 1 4 5. Is there any 1 4 5? Yes, 1 4 5. This term, this and this will be as it is. This. Now we'll see 236 with 2364. By using this, okay, 4 will be eliminating. So by this we'll get 2, 3, 6. Again P2, P3, P6 with 2, 3, 6, 5. Again 5 will be removing. Next again 2, 3, 6 with here 2, 3, 6. 2, 3, 6. So P1 will be eliminating. So finally only one P2 6 will be 236 will be existing with these four terms, that is final P1 P4 P5 plus P1 P2 P5 P6 plus P2 P3 P4 P5 plus P1 P4, that is P3, I will write P3 in order, P4 P6 plus finally only one P2 P3 P6. This is the final minimum SOP. From this Petrix minimized expression will get two solutions, that is with minimum number of prime implicants. Minimum number is here, this is the minimum number and again this is the minimum number. So two solutions, that is P1 P4 P5 and P2 P3 P6. Okay, now we'll check that function f is equal to what will be the SOP, that is 1 4. There is no 1 4. Next 1 5. Yes, here 1 5. Okay, wherever 1 it is covering, we'll check that 1, that is 1 is A bar B bar. Okay, here it is covering 1, that means A bar B bar. Next again here it is covering 1 as well 5. So B bar C plus B bar C plus next 5. Here it is covering 5. Okay, so plus AC. This becomes the final minimized expression. Or you can check 2, 3, 6. Okay, 2. That means F is equal to A bar C bar plus B bar C plus 6. That means 2, 6 or 6, 7. That is AB, or again you can consider that is 6. 6 is covering in two terms. So take one for one SOP and other, that is BC bar, or for other SOP. These are all the two solutions. This is the minimized SOP by using Petrix method.